All right, thank you very much. So thank you for inviting us here. And so I'm a recovering rocket scientist, currently working for Deezmaker 3D printers. And so what's a 3D printer? Well, you can see one right here. We see two of them right here. And so what I'm going to talk about in this presentation is a little history of 3D printing. Talk about different types of printers. These are both the same type of printer. Talk about our entrepreneurial journey a little bit, and Jacob, of course, is the founder of the company there, and he's kindly doing the cheerleading tonight. Talk about life in a startup, and since my big boss is here, I have to be nicer than I might be otherwise. And talk about a little bit for you about why our printers are designed the way they are. How many of you in the audience are engineers, just for fun? Oh, just a few, okay. So I won't go engineering on anything. And these are called triple F printers for reasons that we'll go into. And what would you make? People always say, what can you make with these things? And what would you want to do? So we'll talk about that. And then where you can learn some more. So this is a device that's called an additive manufacturing device. You say, as opposed to what? Well, normally you start out with a piece of metal, right? And it gets smaller. You start with a piece of metal and you go, you drill into it and you make it smaller. Here, what you do is it gets bigger. And additive manufacturing has been around for a long time. It's called the brick wall, right? You take a wall, you put bricks on it. You're doing kind of philosophically the same thing. This is the fancy 2013 version of thinking about that. So, traditional manufacturing, thing gets smaller, here you get bigger. So you probably heard a lot about this since you're here. Presumably you're fairly aware of it all. And the question is, well, where does this all come from? And the reality is that this has all been around for a really long time. The very first patents on this were filed in 1984. A lot of the stuff came out of MIT. I'm MIT alumni, so I have mixed loyalties here, I guess. And one company basically owned this for a long time. So they were big machines, they were expensive machines. The business choice they made was to have big, expensive machines. And so the technology didn't really get out there. And then the patent expired. So completely, there were all kinds of people making these machines. And we have many honorable competitors, and we pity them all. No, so we have a slightly biased slide here of some patents that held back progress, so now I'm not going to go through it, but basically they're all starting to expire now. And so it's an interesting thing, because traditionally you think of a tech startup, the first thing you do is you patent stuff and get out there. Here, what people do is put everything out in the open. And then we all kind of compete on execution and on features and things like that. So it's a very different business model. It's kind of a wide open model. We've had some marvelous partnerships with a lot of educational institutions because of that. So the patents expired, and thus we were all born. So this is what is called a RepRap printer. And what is that, you might say? Well, it's called replicating rapid prototyper. And the idea is that the printer can print itself. Think about that. It's a little science fiction-y, but I'm trying to stay, I know you're recording this, so I'll get away from the microphone for too long, but I'll point at a couple of parts on our printers that were made on the printer. So the original RepRap, the idea was print everything that you need to make a printer except some stuff you can get at Home Depot. And over time that evolved a little bit and got a little more mature, and so now we have these. So what are some types of 3D printing? And I actually hate the term 3D printing because it's sort of weird. Everybody expects they're going to hit print. And it's not really that way because you kind of have a small factory on your desk, and we'll get into that. But the oldest one is called stereolithography, and the A is for apparatus. That's the original patent. Everybody says, why is it SLA? And I'm going to talk about each of these in a little bit of detail in a minute. But basically you can have a bucket of resin, you can have a pan of powder, you can have a spool of filament, you can have paper, you can have some powder and some binder, you can have ground up metal, you can do a lot of different things to 3D print. And it can be from tiny little nanoscale things that you have to look at under a microscope. And there's a guy at USC who's doing entire buildings 3D printed in concrete. It's very tricky stuff. So what is SLA? SLA is basically I have a high-tech bucket that has a high-tech fluid in it of resin. And on the surface of that bucket, is there a pointer in here? So on the surface, you have the fluid here, and it has a surface, and then you have a laser beam that comes down and cures the surface of the resin. And then the platform goes down, gets covered with some more resin. You do the same thing, the platform goes down, you get covered with more resin. So you're building kind of upside down. The nice thing is that you can get a lot of detail with that because it's a liquid. The other thing that's good is that you don't have to support it because it sort of has fluid around it. Supporting things is something we'll talk about a lot. It doesn't waste very much, but it's very expensive. The fluid is expensive, it's toxic, nasty stuff, and there's some issues with cured resin has some problems in how strong it is and things like that. SLS is what a lot of people think of when they hear 3D printing until now. And you have a bed of powder, it's sort of the same deal as what I just described. You have a bed of powder, you have a laser that centers the top layer, the bed goes down, you do the next layer, the bed goes down, you do the next layer, and so on. So you're building still in layers, where you're building from the top. The powder supports whatever you're making, so there's no issues of if something's hanging out in space, that's okay, because it still has powder underneath it. So you can make really complex things, but the powder is very fine. It gets absolutely everywhere, and it's hard to keep the powder really clean and to reuse it and all that kind of stuff. So it has some issues. It's expensive also. The machines are $100,000 to $1 million, and so it's got some issues too. And so we are what's called a fused filament formation, or there's various things that people say that FFF acronym works for, but anyway, we're one of those. And the good part is that the price is pretty cheap. It's down now to, this is considered a hobbyist machine. So there's a lot of us sort of in the sub $2,000 machine. For a fancier printer, it can just do something bigger maybe, but the consumer printers are catching up. It can print a lot of pretty useful things very cleanly, so you can see that's it, right? You have your spools of material, the material feeds down, I don't know if you can see it on the black, and that head where the light is on there is where it's melting. The light is not because it has a laser, it's hot, the light's because there's an LED there to make it look cool. So you don't have a laser there, it's just a little heater. And so these are two of our printers. This one can print up to an 8-inch cube, and the little one is a 5-inch by 6-inch by 5-inch build area. So, you can do quite a few things with that. The only issue is that the detail is a little limited. You can see the lines. If you come up afterwards, you can see things we've printed. So if you want a perfectly smooth surface, you can't really do that with this technology because you're building up with lines that are, half a millimeter or a fraction of a millimeter, but they're still lines. We can go up to, we can do, was it 20 micron? 20 micron is the best we've ever tried layer, which is pretty good, but it's still a layer. So that's kind of the difficulty. And the other interesting thing is if I'm building up, you sort of see this building, it's building up from the platform, if that's not obvious. If I make something that has my arm like this, if I make a statue like that, so I'd be building up my feet, right? And I do have feet over here. I'd be building up my feet and everything else up to here, and then, I'd start printing out to here. So what would happen with it, right? So what you have to do is anticipate that and build up what's called support. So that's an issue with that, and it makes, the software will do it for you, and it fills these thin lines, you have to sit there and pick it off. There's also some ways to make dissolvable support that maybe you are interested in that we can talk about. so now my entrepreneurial journey. This is a sign from Maker Faire in New York. Maker Faire, if you're not familiar, is a really fun event that people make stuff. And 3D printing kind of has been launched partly in Maker Fairs. The next one is in San Diego, December 7th, if you're so inclined. They're all around the world and around the country. Well, anyhow, I saw the sign, I said, hey, it's kind of my life. Because I'm an aeronautical engineer. I worked at JPL on rockets, so I'm a recovering rocket scientist. Then I went to 3D printing, then next I go to Nerdy Derby. So I don't know, Diego, what that's going to be, but that's where I'm going next. So we are a 4-person company in Pasadena, and founded by Diego, who's back there. And that's Mitch, who's our Cameron, who's our software guy. And everybody thinks I'm their mother. So, and we have an intern. It's not pictured here. And so the company makes small printers, and it was a Kickstarter company. So if people know what Kickstarter is, Kickstarter is a crowdfunding site where basically you say, I have this idea and I'd like to make it happen, and you pledge various amounts of money, and if it's successful, you get things. If you pledge a little bit, you get our eternal gratitude. If you pledge a little bit more, you get a t-shirt. If you pledge a lot more, you get a printer. And so we're working off now our second Kickstarter, which was for the little machine. The first one was for the big machine, it was successful. The second was also successful for the little guy. So how do you use these printers? So the first thing you do is you make a digital model. How many of you here have ever made a 3D model of anything? If you work in entertainment, okay, if you're a number of you probably, give them a location. So you use your favorite computer-aided design program, anything that puts out what's called an STL file. And there's lots and lots of programs. If any of you want to play with it at home, there's a marvelous program called Tinkercad, which is free. And it's a web-based program. You don't even have to download anything, you just have to register. So at the moment it's free anyway. And so you can build yourself a 3-dimensional model. You can also scan things. There are 3-dimensional scanners. We have one at the shop. They're starting to be fairly ubiquitous. And those have come down in price, and ours is about $3,000. We don't make them, we bought one. So, you know, they're becoming pretty affordable. Or there's libraries of stuff out there now that you can download things from. And so you can also do that. So you build this 3-dimensional model with a computer, you know, to make a model of something that's 3-dimensional. And then the way that you do this is you save it as a surface. So it'll be like saving the outside of my hands here, you know, so as if I was making a ball. Then what happens is you say, oh, well, I have to take that and make somehow commands to drive that head so it can print. So there's a program called a slicer. And what the slicer does is it says, okay, I'm going to start with this ball. Now, what do I need in the first layer to print it? What do I need in the second layer, and the third layer, and the fourth layer, and the fifth layer? Ooh, you know, is there a piece sticking out here? Do I have to make some support? All that software is open source, which means that it's free. And it's been put out there by the community, it's maintained by the community, and so it's kind of an exciting thing. Because it's open source, it changes all the time. I'm teaching one of the first classes on this for National University online, and people wanted screenshots, and I said, well, it might be different tomorrow. So there's some challenges with open source. The last step is that after you slice it into layers, you have to make actual commands to the printer head. If any of you have ever used a numerically controlled machine, it uses something called G-code, which has been around since the 1950s. It's the same thing that's used kind of to drive CNC machines, so it's been around for a while. The thing that's nice though is that because numerically controlled machines were all built by different manufacturers. So they all kind of have their own dialects of stuff. So if you know one machine, you probably don't know this other one. We can learn it, but it's different. But since 3D printing all kind of came from one well, there's fewer dialects. It's a little bit more consistent. And so I just talked about this. If any of you were here earlier, we can run these off an SD card, and we discovered we lost the SD card somewhere between home and here, so that the slicing software is actually running on my laptop and just doing my slides, which is why I'm doing this sort of odd maneuver here. And if you were here earlier, and I'll bring it up again at the end, you can see it. But basically, the software is just called Slicer, open source. Tinkercad. We did a class for MIT alumni and MIT alum. And of course, we're going to make that something that had our logo on it. That was made in Tinkercad in about 45 minutes. Diego really knows what he's doing. The two of us said, okay, we're going to figure out how to do this. And it's very, very fast. So if you're interested, it's wonderful tutorials. So what else enabled this? Well, there's a type of computer chip standard called an Arduino standard. And it's a very, very low-cost type of chip, and it was designed to be easy to program and easy to learn. It was developed by some Italians a few years ago to teach electronics to grad students. And it became so popular, it's kind of become a standard in the do-it-yourself world, which is kind of exciting. And so both printers run off an Arduino compatible chip called an ASCII. And so there's a lot of people doing very interesting programming and very interesting things, and so we can exploit a lot of that in a positive sense and work with a lot of people doing interesting things. So, well, why would you do this? I mean, why don't you buy one of these, instead of just that, send it to a machinist, right? So the idea is that the traditional workflow is you have an idea, you design it, it goes out the door, the blue part is what's in-house. You send it to a machinist, and you bring it back, and maybe it's okay, maybe it isn't, but you spend a lot of time getting that design really right on the top before it went out the door, right? Because once it goes out the door, it's expensive, it's a contract, it's all kinds of nonsense that goes with it. So you want it to be really accurate when it leaves. That's an important fact, number one. Number two, it might take a while, depending on where the machinist is, what else he or she is doing, all that kind of stuff. So, you do all that, you have a machine, you bring it home, back in-house to test the design, iterate it, maybe go back out again, eventually you send it to a manufacturer. The idea with the 3D printer in-house, the cheap one, is that maybe you can get the design very close if you have this thing on your desk. So instead of agonizing about being perfect before it goes out the door, maybe you dig around a little bit, you do something, you try to say, and maybe you get a lot of the design issues away from you before you actually go and commit to send it to a manufacturer. And, so there's some very interesting things you can do there, and it's just, if it's on your desk, it just really makes a big difference. I like to tell the story that I was at JPL for a long time, and did a lot of flight stuff. And I used to make myself little models out of paperclip boxes. And I'd write on the paperclip box, I'd hang a few things off it with some pieces of Scotch tape. And people always steal my paperclip boxes because they're very convenient to visualize, right? So even just doing quick and dirty things in an engineering environment or a design environment is a really powerful thing. You just have it on your desk to do things quick and dirty. So there are printers that print in metal, mostly SLS machines. And so what they do is they have a bed of metal, and they'll sinter the metal. But we said, is there something you can do to make something out of metal with a sub $2,000 printer? So what we did was some experiments with a sculptor, a friend of ours named Agate, and Art Bronze, which is in Burbank. And so what we do is we print it in plastic. And this is PLA, it's the same plastic that's printed here. And PLA is a corn-based plastic that melts at a pretty low temperature. So it turns out that there's a technique that's been around for a long time called lost wax. And in lost wax thing, you carve something out of wax, you coat it in ceramic, you cut some holes at the top and bottom, you pour in the hot metal, and wax melts out. So it turns out this melts out beautifully. So what you can do is print it. You can even print it with what are called sprues on top and bottom, if you're familiar. So this is bronze made from, not this exact one because it's got melted away, but this is bronze made from 3D printed material. So it's kind of fun, and if you want to make 5 or 6 of something, it's an extremely efficient way of doing that. Because if you have lost wax, you have to carve out each one individually. But if you can do this, you can print some. Once you get to some number, then it makes more sense to make a rubber mold and all that stuff, but we can argue about that later. But I kind of like it because you probably can't see from there, but you can probably see on the slide it has the lines on it so you can see where it was born. Because it was printed this way. And so this one has the same lines on it so you can see where it was born. We had a cool real frog too, but he took a walk off a table at some point and made the last Maker Faire New York. And he's happily in some small child's apartment in New York because it was a kid magnet. And so the other thing that you can do a lot with a 3D printer is reverse engineering. You know, suppose we have a lot of people in Pasadena and probably in Glendale too that have old houses. And you have some wonky thing that's built in, and you have 4 of those wonky things that's built in, and one breaks. Yeah, you tear out your whole wall, or you figure out some way to make one, or you just become a really good customer of the duct tape corporation. And so people have come in and said, you know, I have this thing, it's beautiful, it's broken, can you make a plastic one? We'll figure out some way to work with that. So we've had a lot of people come in and figure that out. You know, and just figure out how things are made, or take something. And basically you can take something virtual and make it real. So if you have a relative that you want to get away from their video games, you're out here on a, some of you are smiling, that's because it's dangerous. You know, if somebody want to get away from their video game, this might be their big chance, because one of my passions is teaching people how to make things, and teaching people math and science through making things. And I know there's a survey going around about whether there's a maker space here at the library. And the ideas that I've been working to is, you know, how do you get people to learn about reality again? Because yes, you build a computer model, but there's real engineering issues in trying to make it work. And I think we think that that's a really powerful thing, like for the high school student or the community college student or the general public that wants to learn that. So just to summarize a little bit, so here are the kind of things that are out there currently with 3D printing. There's the liquid printers. There's one consumer level liquid printer that's sort of being born, I guess. They're also being sued because some of those patents are still out there. How that will play out, I don't know. They can get very high resolution, but they're expensive. There's the powder folks that can make things out of a lot of different things. You've probably been hearing the news some about people making things out of metal. Most of those folks are working in SLS, in powder. There's some interesting issues with that. The way this works is you build up your piece, and then you have to basically cook out the resin and cook out any impurities in it. And that's a less understood process than all the other processes that have been around for a long time. So there's a lot of people working on that, and they need to do that. And then there's us, and us and the more expensive equivalent of us, mostly, which are just mostly bigger. And you know, the cost is low, and you can sort of imagine the limitations here on that. For some reason. So I know there's probably lots of questions, so I'm going to summarize here. So where can you learn more about this? I also happen to be chairing an event in Caltech on November 9th about we call the Arduino economy. And there's the website, Forum, as in Entrepreneurs Forum, .caltech.edu, and it's something like $40 if you register in advance and $10 for students. And that's going to be all about Arduinos and people doing interesting things with Arduinos. Not 3D printing per se, but interesting sensors. Somebody built a spacecraft around an Arduino board, which is pretty tricky, called ArduSat. We have them. And we also have a 13-year-old entrepreneur who has his own electronics company selling different sensors that detect various interesting things, some of which I can't talk about in front of a family audience, even though he's 12. I'll let you just amuse yourself about what a very smart 12-year-old boy can do with some electronics. We also have had a lot of classes. We're having an open class November 17th at the shop, and Deezmaker.com. You can go register for that. We also have an open meeting the first Sunday of every month from 12 to 5. I may like to put the time up there. And if you're just interested in 3D printing, people bring in all kinds of wild stuff for that and to see. So it's a lot of fun. And we're at 290 North Hill, just south of the 210 freeway on Hill, just north of PCC. Or you can ask me, or even better, you can ask Diego, who's standing back there being very patient, since he's the company's founder. So I'll open up for questions. Thank you.
Can I ask you this question? So basically these three methods that you were explaining, so all of them are cutting to a mass that you have, or you're doing layers and then gluing each other to each other?
So the question was, are all these cutting through something, or are they all building up? No, they're all building up. So if you have the powder bed, what it's doing is you have a bed of powder and you have a platform. So let's suppose I was building this. Okay, so let's suppose I was halfway through, like that. So you have this platform, and the platform would center this top part of my finger here, and then move down a little bit, then it would center the next part, and then move down a little bit. So in all cases, you're adding by basically melting with a laser if it's something that's hot. The blue shirt.
Yeah, I have two questions, one real quick and the other a little bit away from your basic field.
Okay.
The first question is, you were talking about you see lines on the product you make. Can those be sanded away so that you have a smooth surface?
So the question was, can you sand? For PLA, you can sand, wet sand very carefully, because it's a low melt point temperature, low melting temperature.
Well, I didn't necessarily inside the machine, but
Yeah.
maybe after it's...
By hand, yeah, and so people do that, or the other option is if you print ABS, which I wouldn't do in here because you need some ventilation for it, you can treat it with acetone and smooth it, so people smooth it with acetone, but you lose some detail when you do that.
Right. The other question is more, I guess, more general, more towards the industrial. I understand that things can be printed with moving parts. Is this correct? Yeah, that they have moving parts on them. And you don't have to do any assembly. Everything's wrong.
And this is chainmail, which I'm failing to take out.
Okay. So it comes out of the printer just like that.
In fact, right now there's gears printing, another set of those, but one color printing, and you can come up and observe.
Great.
Yes, sir.
Is that owl hollow then?
It's not hollow, it's honeycomb. So
It's
what happens
honeycomb.
is that you set in the software what, how much interior support, how much interior cross-hatching you want. So the default is honeycomb.
Oh,
So
so
it's
it's actually
honeycomb
creating a
inside.
support structure inside of it.
Yeah, because otherwise it
How
can.
are you changing the colors then on the gears then? This is.
Oh, that we have the question was how do we change the colors on the gears? We have a printer with two heads called the Duo, and so that's printed with two materials.
Is the material different color then?
Yeah, materials different, so we can print in two colors. Yeah, not on that machine, but on that one. Yes, sir.
You were saying when they start to take out the impurities out of a done product, will that leave any type of like hollow holes in there, or any? Will it do the same? Like, will it make it less supportive as a structure?
The question was if you bake out something that's been made, metal that's been made sintered.
And I'm talking straight with the sand, which we're talking about.
Yeah, so you make something sintered and you bake it out. Porosity is an issue.
Mm-hmm.
For metal, there's a lot of very smart people trying to minimize that.
Minimize that.
You know, so that's a real process thing. The folks at SpaceX are doing a lot of that. I'm not an expert on that. I just bake one. But generally, that's the answer to a lot of people working. That's a real big problem right now, that people working out really hard. We don't have anything that sophisticated at the moment. One reason that we like this process and that a lot of people are interested in it is because it bypasses all that. Because everybody knows what cast bronze is, or cast, fill in the blank. And so we have this artist that's trying to put those relationships together and start offering that as a service. Other questions? Yes, sir, in the red shirt at the back.
How long would it take to like make the pin? I don't know anything.
To make what? I didn't hear the last word.
Just to make anything.
To make anything? Well, since we've been here, we've made about 2 3/4 of these. So these are little keychains that were the low-level gift for people who were in on our Bukito Kickstarter. So we made a few of these in the 45 minutes or so we've been doing that. It depends a little bit on what it is. If it's a very thin thing, it takes a little longer, like that base. You sort of see the pale green base at the far end. That takes a little longer because as the head is going around, we print those in a spiral pattern, and you have to wait for the previous layer to cool a little bit so you don't melt it. So if something's very thin, you actually have to go slower. So there's a lot of trade-offs like that. Good question. Yes, sir, in the stripe.
Assume that we have a model. Is there something which would scan an existing object and create a software which would eventually make it better of the existing model?
Yeah, so the question was, can you scan things? The answer is yes. I mean, we have a scanner at the shop, and they're coming down in price rapidly. You know, we got a pretty good professional one because what happens is because we have, there are only 5 physical 3D printer stores in the U.S. that we know about, and so we're one of the 5. And so it's kind of tricky because people walk in the door and say, "Whoa, what do you do here?" So that's about half the people, and that's cool. So if you want to come in and do that, you're about half our customers. That's great. And of the remaining people, a lot of people come in and say, "I have this, can you make another one?" Or, "I'm a designer and I want to make this, can you help me?" And so it's just, it's just kind of continual thinking about it. But we have one at the shop, and if you want to buy it, or you're doing a lot of it, it's about $4,000 for the software. So it's $3,000 scanner and then $1,000 for the software to make it actually really work. You know how these things are. So it's great share rate.
I have actually 2 questions. One is there any way that you can, stop the process of printing in the middle of printing if you realize that something is wrong and then change the model and then reload it and do it from the, wherever it's stopped?
Not really. I think our super duper expert Rich might get away with that, but it's where most of the time you get out the little spatula, you pry it off, you toss it over your shoulder, you sigh, and you start.
You seem to be at the ground level of this technology to where it's sort of like a hobby and people are making stuff that's useful, but little things. I don't know about the guy at USC that's building buildings, but what's the future of 3D printing? Is there just some huge vision of what these things can do or where they're taking us?
So the 10-year view, we joke about whether you can see 1 year out. The question was, where's this going? And if I knew, I don't know where I'd be, but anyway, personally, I think it's going to divide. There's going to be a lot of specialized printers because, the printers are sort of easy and cheap enough to make that I think, they're going to start to form around markets. Right now, I think there's a lot of interest in education. I also work for National University, which is one of the largest producers of teachers in California, and was trying to offer professional development through National for teachers. And I have some of the flyers, maybe you're interested in that, to teach them to do it. So I think it's a way to teach people to make things. If you don't know, I don't know about Glendale, but LA County has closed most of its shop classes for lack of interest and lack of money. And so we see this as a way to kind of backdoor into teaching people to make things. What can you make from it? I think people are just learning to think this way. I think there's a lot of promise in this for bigger things, but the big thing is designers, is making that process faster. And once it gets a little easier to use and there's more of an installed base, I think people use it to be more efficient at the front of processes and to customize things. Yes, sir.
When I mentioned I was coming to this thing, like a couple of days ago, people immediately said, "Oh yeah, 3D printing pizza, and 3D printing skin, 3D printing organs." I heard all this from different people, this kind of science fiction stuff. Skin, pizza, what are they talking about? I haven't,
Well, skin is not that different than this. What they're doing, and I'm not an expert on it, the question was printing skin and printing organs. They're printing a scaffold because a lot of people who make artificial skin and stuff, there's some of that already anyway. And so you can print basically a scaffold and then drop living cells in it. So the idea is you're printing like a sugar scaffold. So it's not really very different than this. You're just basically printing someplace that cells can be happy and then go later.
But you could cook pizza on there, right?
Well, I don't know about the food stuff. Basically, I think they have some kind of, generic ooky starch and some kind of flavoring for it. We're not a food safe printer. Although Diego fantasizes about food printers all the time, but we're, you know, people are playing around with food things on the space stations. I mean, we're just trying to help designers. Yes, sir, the ratio.
If I brought like something in the size of that album and you guys scanned it and made me look at it, what sort of cost are we talking? Is that what's for time?
Well, for scanning, we're still kind of figuring that out. So we got our scanner very recently, so it sort of depends on how complicated it was. Things that have holes and undercuts are a little more complicated. For printing, we charge $25 setup fee and $1.50 per cc of material, which might be a lot less than the physical volume because a lot of it's going to be hollow, or it might be more if it needs a bunch of support. So we have a piece of art very soon. But I'm not supposed to advertise here, so I won't go. You can see me later.
What's the dimension? How big and how?
The dimension of this printer?
Scanner.
This printer can, oh, the scanner?
Yeah.
The scanner we have is by somebody named Next Engine, and it's been advertised heavily by Jay Leno, who has a bunch of classic cars, you may know. So he's been using it for parts for his classic cars. And so it can scan things. It has a little platform, and so in one mode it just spins around and you scan it with 2 laser beams. But there's another mode where you can put some fiducial dots on it and scan things the size of a car. So I mean, it's we haven't tried anything that big yet, but supposedly that works. We just haven't gone out to the parking lot and tried it yet. So. Any more questions? Yes, sir.
Another question. So what if you have a small printer, 3D printer, and then you have a bigger model? Is there any way you can do it in parts and then do it or somehow make it one piece? Or?
Yeah, so the question was, if you have something that's bigger than the bed, can you make it into pieces? Yeah. And there's some software that'll help you slice it and you can glue. As long as it's something that's okay to glue mechanically, you know, and it's in a material that's glueable mechanically. Yeah. So I think probably I'll stop now and let people come up and actually see them because they're kind of a visual. So, you know, thank you so much to the Glendale Library folks for having us here. And again, I'll acknowledge your way.